Okay, so this is a railroad crossing gate. So the center of mass of my gate is right there. It's 0.75 meters above the ground. We've got a counterweight. Okay, so this is the counterweight location. And the counterweight location is, this is 1 meter above the ground. This is 0.5 meters from this spot there. Okay, that's 0.5 meters. This is 0.25 meters. Okay, and I do have that 2.5, okay, 2.5, all right. And I don't think we actually need this height, and I'll show you why here in a second. So this is point A. This is the location for the counterweight. This is the location for the gate. We're given that the gate has a mass of 100 kilograms. The counterweight is 250 kilograms. And we want to find the moment at A. Okay, and this is point B for reference for the pole. So I'm going to do the force due to gravity, or the weight of A, which is just going to be 100 times 9.8, which is going to give me 980 newtons. For my counterweight, it's going to be 250, 9.8, and that's going to give me 2450 newtons. So if I do this, okay, do the moment about A. So I'm going to look at A here. This is my counterweight. So this is A. Counterweight. I have this there at, so this is 2.5 away. This is 0.5 away. This is 2.5 away. Make sure I've got everything there. Oh, and this is 1 meter from the bottom. So if I do the moment for FGA, so this is the moment for this, from my point A, that's going to give me my matrix is going to look like this: I, J, K. I've got 0.25 from the wall to that, so that's going to be, it's negative 7.25, because this is my R vector for this spot from that one. So it's negative 2.75, this is this part right here. If I look at it, there's this to that. I didn't draw it right down here. That's negative 2.75 from there. Minus 0.25 from here to here, my down part. because this is 0.75, this is 1 meter to there. Difference between the two is 2.5, and it's 0 in the K. And then I've got 980 in that direction. So that's going to end up being negative 2.75 times negative 980 in the K direction, which gives me 2695 in the K direction. So that's the moment about K for the gate portion. I can do the counterweight, okay? Do the counterweight, the moment is going to be, for the counterweight, I get I, J, K, and initially it looks like they don't give us enough information because I'm 0.25 away that way, and the X direction says 0.25. I'm not told where the J direction is, so I'm going to put in a question mark there just to prove to you I don't need to know. Exactly. Negative 2450. So that gives me negative 612 in the K direction. So I got the two moments. So the sum of the moments is going to be 269 minus 612.5 equals 2080 Newton meters. And that's a railroad crossing bridge piece. So while moments look like they're more complicated, at the end of the day, they actually end up being easier. Because if you think about it, remember when we did this, these problems like this? So I have a person on this side of the teeter-totter, and I needed to find the person on that side of the teeter-totter. And if this person was 40 newtons, and this person was 80 newtons, I had to balance it out. And if this person is 3 meters away from the rotation point, and I want to know where that person needs to be, that's 40 times 3 is equal to x times 80. So I get 3 times 40 divided by 80 is going to give me, that just becomes
6.
That becomes what, 1, yeah, 3 divided by 2, right? 40, yeah, 40 goes into 80 twice.
Yeah, so you're
It's 3 divided by 2, x.
why? So why? Is that gonna be on the test? That's really easy.
No, we're not doing moments on this test. Moments are on the next test. And the next test is March 13th.
Okay.
I can tell you the next test is March 13th. And which means, Hannah, you got to do yours ahead of time.
For the top one, couldn't we just do the force times perpendicular distance?
That's what we do.
Yeah, you don't really have to do all that.
No, you don't have to do all that. No.
Yeah,
Some of the homework you do, this is an easy case where you can just do, and a lot of times we actually are going to set it up to do just the perpendicular distance. Well, ultimately set it up just to do the perpendicular distance. And that's where we're starting right now. So, okay guys. So for those of you who don't have calculators, calculus. This is one of the places that we're gonna actually show the calculus, so don't panic. Okay? Don't panic. Because what we want to do is we are going to end up doing finding the moment about a specified axis. So what happens to us is if we've got, this is x, and this is y, and we're at a point origin there, and I am going to have a lever arm out here somewhere, and I've got my force coming up here, so I'm going to do this, so this is some incremental x. I'm going to have some incremental y, and this is the distance that the force is being applied from the origin. And that's our angle. So if I've drawn my picture correctly, so this is a force, and this is the magnitude of the force along a k direction. Basically what I'm getting is my perpendicular distances, I, J, K. This gives me some incremental force, or incremental x direction, incremental y direction. So it looks like that. So the moment in the x direction is just going to be the force times my incremental x. So your idea of just doing my perpendiculars comes right here. And then I do my y's there, I get my incremental y's.
Shouldn't it be moment on the x is equal to f dy?
Let's see, dx to df, nope.
Well, if you multiply it out and cover up the I, then you're left with dy.
Okay, let me write it out. You end up with a dx dy 0, 0 in the k direction minus dy 0, 0 f in the j direction plus dx f 0, 0 in the I direction. So this becomes the moment in the x. This becomes the moment in the y.
But if you cover up the I, and you just multiply f times dy, and then minus 0 times 0.
That's this right here.
Okay. Yeah, because you cover up the I,
I cover up the I.
and then the I is equal to dy times f minus 0 times 0.
I see what you're saying. Did I write it out right? Yeah, I did dx dy. Did that right? We still in get the. I'm going to double check it, because what you end up with is we can say m, well, this is the moment about the x direction, moment about the y direction. So you end up with MAFDA for any general. I'll have to double check it, I don't have my book in front of me. I've got my notes. They're magnitudes only. And it's scalar form. And we can bring in, I'll double check it, but we can bring in, we get MA for any vector, unit vector in the A direction, dot R cross F gives us, we get MA is equal to whatever our unit vector is in the x direction, unit vector is in the y direction, unit vector is in the z direction, Rx, Ry, Rz, Fx, Fy, Fz, which gives us a moment about whatever our a-axis is, our unit vector in the a-axis times the moment of a. So if I do that, so we can work the problem, like I said, I will double check it, but work the problem. Okay, I've got pipe. This is point C, this is point B. I've got a force that's being applied here of 50 newtons. That's 60 degrees. I've got a force that's being, and this is A. I've got a force that's being applied here, and we're told that this is a 12, 5, 13. This is at 0.4 meters. This is at 0.3 meters. If I do this, I'm going to go ahead and write out cosine of the angle is equal to 12/13. Sine of the angle is equal to 5/13. So if a 50 Newton force is applied as B, determine the moment about C. So we're wanting to determine the moment about C. And if I do this one, I get 50 sine of 60 is equal to 43.3 newtons. And I get 50 cosine of 60 is equal to 25 newtons. So if I do for the 50 force about C, I get R cross F is equal to I, J, K, 0.300 minus 25 minus 43.30, which is going to give me a negative 13K newtons. And because it's negative, it's rotating that direction. Now, this one, we're just going to call F. We want to find F such that M due to F is a plus 13K newtons. So we want to find it so it's going that direction. So we need to know what the counteracting force is to counteract that moment. So we do the R cross F. This is I, J, K, 0.40, 12F, 13, 5F, 13, 0. We do that, we get negative 0.4 times 12 13s F is equal to negative 13 newtons. Solve for F, and F ends up being 35.2 newtons. Oh, and by the way, because I did extend the homework, if you've run out of tries, I tried to go in and give you more tries. So if you've run out of tries, because I extended the homework, write out your answer and give it to me on paper, and I will give you credit for it. I tried to go in, and if I went in, it made me set everybody's reset to 0, like you'd lose all your work, and I didn't think you guys wanted to do that. Now, if you're like me, I'd had it written out, and I could just go in and type it back in, it wouldn't have been a problem, but for some of you, that may be a problem, so I didn't do that. So, so don't worry about the number of tries on the homework, because I know some of you tried to do a crash course to get them done in. Why nobody emailed me and said, hey, we haven't covered any of chapter 4 yet, and yet the homework for chapter 4 is due like today. I should let you all suffer your own consequences. But I'm not going to penalize you tries.
So if I miss one on one of the homeworks, if I do it and then I give it to you, do I still have to do the follow-up? Because I got an 89 on it because of that.
But you're going to have to email me to remind me so that I don't forget.
I haven't even done it yet, so.
So, then you got all your tries, so it's no big deal.
Thank you for extending it, by the way. That was kind.
Yeah, see if I want to do another problem or not. Because I'd like to get the really good pictures, because I'm doing these with my sketches, which is always ugly. Oh, we could do an open up a valve. Oh, that's when we define a couple. I don't necessarily want to define a couple yet. I think I'm going to stop, guys, because I don't want to define a couple yet. You got a test, and I don't want to put this one up without a nice picture. We'll come back on Monday and define a couple and we'll do some nice pictures. Okay.